Hey everyone, it's Bradley Bush with another algebra video for you. Thanks so much for coming to my channel. Hope you enjoy it. Today we're talking about identities, conditional equations, and inconsistent equations. If you find this useful, please consider subscribing to the channel, giving me a thumbs up, or leaving a comment. Here are three types of equations. The first type is called an identity. An identity is something that is true for all real numbers. It doesn't matter which number you choose to plug in for the variable x, it's still true. So an example would be x plus 2 equals x minus 3 plus 5. If we chose something to plug in, let's choose, say, x equals 1. So if I plugged in 1 here, I'd have 1 plus 2, which gives me 3, equals 1 minus 3 plus 5, which also gives me 3. So 3 equals 3. Now, if we chose something else, say we chose x equals 5. So I'm just choosing another value. I plug 5 in here, 5 plus 2 equals 5 minus 3 plus 5. So on the left I get 7, on the right I get 10 minus 3, which is 7. So I got the same thing on both sides, so it satisfied the equation. So it was true for the value x equals 5. And as we look at this, just doing these two examples doesn't mean that it's an identity. It just means that it's valid for these two examples. But if we manipulate it a little bit and we realize that -3 and +5 really are just 2, this really becomes x plus 2 equals x plus 2. And that's true for any value, any real number you plug in, right? So that's what we call an identity. It's an equation that's true for any value, any real number you plug in. Let's move on to our second kind of equation. Our second kind is called a conditional equation. A conditional equation is an equation that is true for at least one real number. So it's not true for every real number, but it is true for at least one. Let's look at an example. 2x minus 3 equals 17. If we plugged in, for example, x equals 10, let's plug in x equals 10. That gives us 2 times 10 minus 3, which is 2 times 10 is 20 minus 3 is 17. So we get 17 equals 17. So it's true. It's a valid statement for x equals 10. What if we tried something else? What if we tried 4? So 2 times 4 minus 3. We get 8 minus 3, which is 5. Does 5 equal 17? Nope, it doesn't. It's not valid. So it's not valid for other values. It was valid for 10, but it's not valid for 5. But it's okay. That's what a conditional equation is. It's an equation that is true or valid for at least one real number. Let's look at our third type of equation. Our third type of equation is called an inconsistent equation. It's an equation that is not true for even one real number. It's not true for any real number. So let's look at an example. If we have x equals x plus 7, and we say x equals, let's let x equal 1. We plug 1 into the left, and that 1 equals 1 plus 7, and that's 8. Does 1 equal 8? No, it doesn't. Can you think of any number this was hold for? So if we just think about what's happening here, we're taking a number which is represented by the x on the left side of the equation. On the right side, we're taking that same number and adding 7 to it. So can you think of any number that is the same as itself plus 7? I can't think of a real number. Even if you try 0, 0 equals 0 plus 7, which is 7. So does 0 equal 7? Nope, it doesn't. There isn't any number, any real number, that you can take it and say it is equal to itself plus 7. So this equation is not true for any real number. So we call it an inconsistent equation because it does not have a solution. The only solution is the empty set. So again, a review, identities are true for all real numbers. Every single real number, doesn't matter which one you plug in, you'll get a true statement back. The conditional equation is the second type of equation, and it's true for at least one. It could be true for more than one. It could be true for actually a lot, potentially, but at least one. And the inconsistent equation is not true for any real number. So not even a single number will work. Hopefully this was helpful. Thanks for watching and have a good day.